In this video, we are going to talk about the last type of transformations, which is reflection. Reflection across the x and y axes. Given y is equal to f of x, then y is equal to negative f of x. The graph of that will be the graph of f of x reflected across the x-axis. And then if we have the function y is equal to f of negative x, so in the first one, the negative sign is applied to the whole function, the whole parent function, while the next one, the negative sign is only applied to x. So in this case, the graph of f of negative x is the graph of f of x that is reflected across the y-axis. When you transform for the first scenario, where y is equal to negative f of x, you will transform the point xy to the point x negative y. You just add negative to the y coordinate. And then vice versa with the y is equal to f of negative x, transforming the point xy, you will change x to negative x and then keep y the same. Let's apply that to example 5. The graph of y is equal to f of x is given. Graph y is equal to negative f of x. So this time in this problem, they don't even give us what the function f of x is. They actually give us a graph of the parent function f of x. Now we have to graph y is equal to negative f of x by transforming some points. So I can already see 4 points that are marked on there. I'm going to choose those 4 points. This point here is 0, negative 1. This point, this will be 5, 0. This is 4, 4, and this one over here is 3. So not 4, 4, but that would be 4, 2. So let's transform each of them. With y is equal to negative f of x, all we have to do is just add negative sign to the y coordinates. So the points will become 0. Instead of negative 1, we are going to have 1. So it'll change to 0, 1, because we are applying the negative sign to the y coordinate. 5, 0, keep 5 the same, 0, negative 0 still gives you 0. 4, 2, this will become 4, negative 2. And then 3, 2, this will become 3, negative 2. So let's plot 0, 1, this point, 5, 0, so the same point, 4, negative 2, and 3, negative 2. Now you connect, you get this graph. Do you see that this is basically the original graph f of x that is being flipped upside down, which is consistent with the saying that the graph of negative f of x is the graph of f of x that is reflected across the x-axis. So the x-axis acts like a mirror, and then one is a reflection of the other over that mirror, which is the x-axis. So now let's try the second one. This time we have y is equal to f of negative x. So with the points that we identify in the f of x function, which is the black graph, we are going to change all the x values to negative and then keep y the same. So 0 will become, well, negative 0 is still going to be 0. 5 will become negative 5. 4 will be negative 4. And 3 will be negative 3. Plot these points. So 0, negative 1. Negative 5, 0. negative 4, 2, and negative 3, 2. Connect these dots, we have this graph. So do you see that the orange graph that we just drew is the reflection of the black graph along the y-axis here, which is why we say the graph of y is equal to f of negative x is the graph of f of x that is reflected across the y-axis. So the y-axis now acts like a mirror, and the orange graph and the black graph are the reflection of each other. Let me correct this one. The 0.3 negative 3, 2 should be here. And there you have it.